Well, hydrogen is everywhere. I mean, it's the first element on the periodic table, atomic number 1. I mean, it's the weight is just so minute, but it's combustible, and it's highly combustible. If you look at the charts as far as gases, it's right there up with propane. Propane and hydrogen are almost exactly the same as how they combust. But yet, we've been bottling propane for years for our gas grills and forklifts, some industrial uses, and also hydrogen, but it's never really taken off. And you wonder, why this process is so inefficient. And you just kind of dig and you dig, and I came up with this epiphany of trying to take it and compress everything. You've got these big plates, trying to conduct, and I was like, why do you gotta have so many plates? And you don't. So it was amazing because I learned, by looking at this, that I can take just two plates of any given size, just about, and I can put them together with the right type of materials, and I can actually coil them up into a cell. So I can take several hundred square feet and I can compress it down into a very small area, and still not only maintain the production but increase like it just. I'm not sure what the numbers are yet. We're going to have to get some good equipment to get a real good measurement, but it looks like about 3 to 4 times the amount of hydrogen is produced from this, just by the way it's designed. It's convective, so it's as soon as it starts to produce, it starts drawing water, up from below, while the hydrogen and the oxygen rise to the top. So you get this suction, this convection. And originally, when we did this, we designed it with a pump, and I had a pump hooked up to push this through. But as soon as you see it, just go. So you take these 2 plates and you put them together, and then you roll them up, and you get this very strange magnetic field. It's really quite phenomenal when you look at the magnetic field. The way it goes is this big, large oval. It's got this open center, but everything is pointing outward, in the direction of the oval. So as you follow the line around, everything fans out, evenly all the way around. And why it exactly does the way it does, but it is linear. So and that's kind of where we come up. It's a linear induction type of cell. So the water is inducted through the bottom, and then that turns into oxygen and hydrogen at the top. So by the time it gets to the top, it's separating. But if you watch it and you see it flow in that video from the top of that cell, and you can just see it shooting out almost. The hydrogen is just streaming out as quickly as it's coming out, and you can see it actually creates a little bit of a suction around the edge where the bubbles are suspended. And as you crank up the power, it gets a little bit thicker because it's pouring off so fast. So this is definitely, I think, one of those things that if we can get it to a market, this is something closer to on-demand hydrogen in a vehicle than I think the world's ever seen. The best we can do is put it in tanks right now and fill it up at the pump, and now they want to charge us, $4 and some change for equivalent gallon of fuel in hydrogen. Doesn't make sense. We talked about on-demand hydrogen and being able to produce it, and somehow we've never gotten any further than what we've seen. So this would by far be the furthest along that we've ever been or ever gotten. In hydrogen production and being on demand, because you can take 2,000 square feet and I can condense it into about a 1 foot tall by a 3 foot circumference, and that's 2,000 square feet of production. You could produce several car's worth of on-demand hydrogen with that. So there's a lot of unique things I think that go into this. I think there may be some other applications as well. But anyway, it's definitely worth examining.